for your very fascinating and inspiring lecture. You also made me realize something about my own work. You know, I'm a computational physicist, and on computers there are only integers, and the only zeros and ones. So it's all created by God. So we are on the same side.
Yeah, with Schrödinger, I would agree with you. Right?
So are there questions? We're all stunned by
you said you think Belinsky-Khalatnikov-Lifshitz is maybe bullshit, it's wrong to pick.
Yeah, maybe that wasn't the most elegant word.
I mean, I guess, it's true that you can think maybe of the Big Bang as a smooth thing, but suppose you are at the end states, right? When you create the black hole, right? And you are sort of in the forward direction. Because you could argue in calculating the backward direction, you end up with chaotic dynamics, and maybe there is something not right in the thinking. But I mean, we always hear, I'm a physicist, we always hear these things about the tidal fields, which make things messy, and you get all these crushing things. So how to avoid this then in the...
Well, Hans presented your mechanism. I mean, this is a beautiful new result today that he presented. It complements the one I mentioned, that you can actually set up a framework at the singularity which doesn't see any Belinsky-Lifshitz-Khalatnikov behavior. I think it's very much open. I mean, the questions are extremely complicated, and just conjecturing this was, a physicist thinking. Hans, maybe you what's your vote on Belinsky-Lifshitz-Khalatnikov? Is this true? And he really opened this subject in understanding how the Bianchi-9 metrics work. I mean, already this simplest system was completely speculative until his work. So.
You can't control these uniformly. I mean, you can think about how would one observer create this universe, how would one observer experience this, and perhaps you're not going to be able to sort of control every observer. So, say for generic initial data, maybe you can control generic observers. You can say something.
But will it be KL or will it be in question?
Well, I mean, well, it depends on the setup, right? I mean, okay, if you're high enough dimensions, but okay, I mean, it depends on what matter models you have close to the singularity, right? If you have a scalar field, well, then that's going to kill off the oscillations, and then you.
So maybe the physicist point of view, right? I mean, we do have fields that they're going to kill off BKL anyway, so we shouldn't care.
Yeah, you can always say there's quantum foam, right? And that kills off it.
Use words.
It also depends on exactly when that sets in, right? Because, I mean, even the quiescent models, you can have, I mean, so if you look at the quiescent ones, it can behave very much like an oscillatory solution for any amount of time, and then at the end, the scalar field is going to take over it and make it quiescent. If you could have, so this is,
Maybe this is a good subject for discussions later. Have a glass of wine. So let's thank Piotr again for a great musicians are so kind and they will play another turn off the lights here for them. Now, next year, October 25th, there is a big celebration because Johann Strauss was born on October 25th in the year 1825. So next year will be his 200th birthday, and there are many events here in the city celebrating that. And in honor of Johann Strauss, celebrate his birthday, our musicians will play not a waltz, but a polka by Johann Strauss, the son. Please. So this basically concludes our afternoon. I would like to invite all of you to join us in the common room for some food and drink. It would be great that we can be, to be together some more time this evening, and I'm sure that Piotr will be here so you can ask him any kind of question. And now I'm wondering if we are lucky and we will get it seems the answer is yes.
Play again a piece of Christmas concerto from Corelli. And afterwards, we are playing four melodies of famous Christmas songs, but very old, very old. And at the end is one Christmas song, Ukraine Christmas song, very famous. You will know it, but you don't know that you.
second, before we move over to the common room, I don't want to finish without saying thank you. I would like to say thank you to our musician for the beautiful music they play. I would like to say thank you to Piotr for all his scientific achievements and his very valuable work in the Faculty of Physics of our university. I would like to say thank you to the members of the Scientific Advisory Board for all their work in selecting medal winners. Of course, I would like to thank the speakers of this afternoon who contributed so nicely with their talks. I would like to say thank you to you for coming, but I would also like to say thank you to Sophie and Maria and Beatrix and Roxy for all their work they did in preparing this afternoon, and we will enjoy what they organized later in the common room. So thanks a lot to everybody, and now it's over, and thank you.